Hello everybody, welcome to week 3 part 2. In this part of week 3 presentations will provide an introduction to the topic of pointers. Pointers are variables that contain memory addresses as their values. They are easy and fun to learn. Like we said in part 1, C++ tasks are performed more easily with pointers, such as dynamic memory allocation cannot be performed without pointers. With pointers, each variable and program is stored at a unique address. So we use the address operator ampersand to get the address of a variable. So as you see in this example on the slide, int num is equal minus 99, cout num, this will print the address in hexadecimal. So the address of num variables will produce outputs in hexadecimal value or hexadecimal value. Pointer variables. Pointer variables are often just called a pointer. It's a variable that holds an address, and because a pointer variable holds the address of another piece of data, it points to that data. So pointer variables are yet another way using a memory address to work with a piece of data. Pointers are lower level than arrays and reference variables. This means you are responsible for finding the address you want to store in the pointer and correctly using it. How do we initialize pointers? Pointers can initialize at definition time. So in this example, if you have an integer num and the pointer for the num integer will be displayed like that. So you cannot mix data type. So if you try to define cost, this example as double, and then also define the pointer as integer for the variable cost, that won't work. So they have to be the same data type. You can test for an invalid address for a pointer with if not pointer. To compare, you use these operators that you see on the screen, like less than, greater than, or equal to. These can be used to compare addresses in pointer. Comparing addresses in pointers is not the same as comparing contents pointing at by pointers. So for example, if pointer 1 equal pointer 2, you are like, if you have a variable called pointer 1, ptr1 is equal to ptr2, at this you are comparing addresses. But if you put the star in front of the ptr1 and the star in front of ptr2, you are comparing contents. So this is how you define a point variable, and this would read as the int ptr can hold the address of an int. The spacing in definition does not matter. So if you put the star, if you put space between the int and the star, it's the same as if the star was right next to it. Assigning an address to pointer variable, basically you just define your pointer variable and then you assign it the pointer. So you would say, for example, int star int ptr, and you can say int ptr equal ampersand num. And this also, you can see the memory layout of the pointer variable. So the variable num can hold the value of 25, and the pointer is pointing to the variable in a hexadecimal value. So the address of the num value is hexadecimal value of 0x4A00. In this program example that you see on slide 4, you can see how the address of a variable is stored in a pointer. So you have the integer variable x and the pointer variable ptr. So ptr it can point to an int variable, um, and the ptr ampersand x stores the address of x and ptr. So the value of x would be x, and the address of x is ptr. So the output, the value of x is 25 because that's the value of the x, and the address of x is the will be the hexadecimal value of the of the pointer location, the variable location. So arrays and pointers. Arrays are similars in pointers, and the relationship between them is like with arrays, you have the array name as a start and address of an array, and an array name can be used as a pointer constant. So like you have int value, you have three values for 7, 11, and the values of the for example, if you want to print out the pointer values of L, that will display for um, pointers can be used as an array name as well. This program you can see how can an array name being dereferenced with the star operator. So if you look at the array numbers and you look how it's been dereferenced with the star operators down in the output, and you can look at the program output and see that the first element of the array is 10. So star the numbers, basically it will point to the first element of the array.